In this recording, we're going to learn how to simplify exponential expressions. Now, an exponential expression is one in which you've got some variables raised to exponents. And our task here is to make this complicated beast a whole lot simpler. Okay? So you might say, well, what is not simplified? How will I know? Well, it can't have any negative exponents, first off. It can't have any exponents outside parentheses. And you can't have a particular variable more than once. I can't have y in the numerator and y in the denominator. If you've got a way to go about this, I say go right to it. But if you're like many students who look at this question and say, I don't know where to begin, I have over here in blue a suggested order for the simplification process. You don't have to abide by this order. It's not like PEMDAS, where you will be wrong if you don't do it this way. This is just a way to ensure that you do get it all simplified, and I find it to be an easy way. Okay? So write down the problem, write down the directions, write down this suggested order, and when you're ready, play the recording. Okay, so hopefully you took time to write down the suggested order as well as this particular function, or this expression. All right, so the first thing I'm going to do, according to my list, is exponents outside parentheses. So I've got this 2 here. I'm going to distribute it to all the factors in the parentheses. So I've got 2 squared is 4, y to the 4th squared is y to the 8th, z squared squared is y to the z to the 4th. Came out like a 9. Let's make it better. 4, y to the 8th, z to the 4th. Then I've got the remaining factors. I'm just going to recopy them as they were. I encourage you to make your z with a little line through it so that it doesn't look like a 2. Okay, check, done that one. Next, I'm going to deal with negative exponents. Okay, negative exponents are not considered simplified. Use a different color here. Negative exponents we're going to bring to the other side of the fraction and make positive. So I see a positive exponent, it's 4 to the 1, y to the 8th, z to the 4th. But when I get to this x to the negative 2, I bring the factor to the denominator, bring that power to the denominator, and make the exponent positive. Z squared, leave it. Go to the denominator. Any positive exponents are fine, they're considered simplified. But this y to the negative 3, we're going to bring up to the numerator and make it a positive 3. Z squared on the bottom. Okay. Now I'm going to go to the more than one instance of a variable. It's not considered simplified if you have x's or y's written in more than one place. So the 4, leave it. Y to the 8th and y cubed are together in the numerator, so I can combine them. Altogether, there's 11 factors. The z's in the numerator can be combined. Your product property, add the exponents. You guys know that. Down in your denominator, x and x, well, there's 5 factors of x altogether, and then z squared. Finally, final step, I have z's in the numerator and z's in the denominator that's not considered simplified. So 4y to the 11th. For the z's, I ask myself, where are there more factors of z? Of course, the top. How many more? There's 4 extra on the top, so that means z to the 4th up on top. Keeps coming out like a 9. Let's make a nice 4. And on the bottom, we have our x to the 5th. That's considered simplified because it does not violate any of these situations. There are no exponents outside parentheses. I don't have any negative exponents anymore. And I only have one instance of each variable. Check, done. All right, let's do one more together. Okay, why don't we grab those steps from before and paste those in for our use. And why don't you get as far with this one as you can, play the recording when you're either stuck or you're looking to see if your answer is right. Okay, so hopefully you took time to do this as far as you can on your own. If not, pause and play it right now. We're going to go through our steps. Exponents outside of parentheses. Don't have very many of them, so that won't be too much work. Just going to recopy everything, except you know what? This a to the 0, I'm just going to put a line through that. That's a 1, right? Anything to the 0 power, assuming a is not 0, is a 1. So I won't even write that. I will write the b to the negative 3, a to the negative 5, b to the 6. Now, if you did this in a different order and get to the same correct answer, great. I have no problem with that. Many correct ways to go about this, but this is just a way if you have no other alternative. Done. Next, negative exponents. We know what to do with those. We're going to take any negative exponent, bring it to the other side of the fraction. So this b to the negative third goes down to the denominator, positive exponent. A to the negative fifth, other side of the fraction, positive exponent. B to the sixth stays put. It's a positive exponent already. A cubed stays in the denominator. It's a positive exponent. B to the negative 7, however, comes up to the numerator because it's a negative exponent. It becomes positive. And same with b to the negative 20. Done. Finally, more than one instance of a variable? Well, I sure have a lot of b's up in the numerator. Let's take care of that business. Okay? B to the 6th, B to the 7th, B to the... What did that come out negative? Let's fix that. Get a little eraser here. We got to take care of that. That should have been a positive. I'm sure you were screaming at me when you saw that. Hopefully you caught that little mistake. All right, so all together, how many b's in the numerator? Well, there are 33 factors of b up top, and 3 still in the denominator. There are 8 factors altogether when I add the exponents. And then finally, our answer, because I've got b's in more than one place, I've got 33 factors in the numerator, 3 factors in the denominator, so altogether, where are there more? Up top, how many more? 30 more, right? Subtracting. And on the bottom, a to the 8th. So again, this would be simplified because it doesn't have any of those situations that we were trying to avoid. Thanks for watching.